Hey everybody, I'm going to walk you through this slide deck. So today we're going to learn a little bit about strings. We've already been using them, so this isn't a big deal, but I do have a couple of new things. And then there's a day 15 coding activity. And be sure to do the coding activity and turn it in before midnight tonight so that you can be marked present for Wednesday the 16th. All right, strings. So strings are pieces of text in Java, and we've already been using strings when we printed things or when we asked the user to enter their name, for example. So here's a line where we're printing a string, and here's a line where we're creating a string while we're asking the user to enter something. What you probably didn't know is that strings are objects in Java. And to contrast that with other things, we're going to back up and look at other variable types we've been using. So Java has two primary variable types. There's primitives and there's objects. And primitives that we've been using so far are integers, which we call ints, and doubles, and then also booleans, statements, expressions that are either true or false. So the object variables we've used so far mostly have been things like the frog class or the scanner class. We've been using strings, and then on several other days I've had other things. Remember, we had rectangle, circle, square. Those were other objects that I created to give you examples. So one key attribute of object variable types is that they can have methods. So primitives don't have methods, but object variables do have methods. There's other things that are really important that are different between objects and primitives, but that we'll learn about that later. So for now, things like strings and frogs and scanners have methods, and primitive variable types don't have methods. They just store data. So we can create new strings like we've been doing. Here's an example string, slogan equals. It's a great day to be a tiger. We just created it all on one line. Or we can create strings using the new keyword. This is how you would do that. In practice, we almost always do it the first way. I don't know who would do it this other way, but you needed to see it, so I showed it to you. String objects are immutable. Now, immutable, if you look up what that means, the dictionary definition means unchanging, means something is created and cannot be changed. In Java, what it really means is that string methods do not change strings. So let's look at a little bit of an example. I'm just introducing to you right on the spot a method of the string class that is to uppercase. And what it does is it makes something uppercase. So let's look. I'm saying string name equals Hayes. And I'm printing name dot to uppercase. So then we get an uppercase version of Hayes over here. So what I want you to understand is when we make this name dot to uppercase call, it returns an uppercase version of the name variable, but it didn't change the name variable. See, on this next line, I'm printing out name again, and it's still lowercase. In fact, this is a common mistake that I see people do this next line, line 4. People put a line like this in their program thinking, okay, that's making name uppercase. It doesn't make name uppercase. It gives your program an uppercase version that's just a temporary thing that goes away. Because see, look, on line 5, when I print it, it's still lowercase. If I want to replace name with an uppercase version of name, I have to do what I did on line 6. I say name equals name dot to uppercase. That replaces the whole variable with the uppercase version of the variable. So a common mistake down the line is that people think that this line 4 does something to the variable. This line 4 does nothing that matters in this program. It creates a temporary version of name that is uppercase, and it throws it away because you didn't store it in a variable, you didn't print it. So it's like that. Line 4 is like it's useless. It's like nothing even happened on line 4. I mean, nothing lasting happened, as shown by line 5, where when we print it out, it's still lowercase. Line 6, however, powerful line. It says, hey, we're going to replace the name variable, whatever's in there, with an uppercase version of that. And that's like a permanent replacement. So line 4 and line 2 are examples of string methods not changing the contents of a string. It's giving you a changed version temporarily. In line 2's case, to print it. In line 4's case, it's useless. That's sort of bad code. But that's what we mean by things being immutable. And we already learned about string concatenation in Unit 1. Here I'm asking the user to enter their first name and their last name. And then I'm making a new variable called full name, and I'm just saying first plus last. And the plus sign concatenates strings together. That's kind of bad code, I realize right now, because you'd want to have a space between the first name and the last name, but we'll get over it. Here's another example. String greeting equals ho. All right, and the next line I say greeting plus equals ho. That means greeting is going to be equal to whatever it was plus another ho. So over here, see it says ho ho. And then I'm now saying greeting plus equals greeting. That means take greeting and add it to itself, twice. So we have ho 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 ho. And that's as far as I'm going to go with the ho hos. Although I'm hungry, and a ho ho, I might even eat it if there was one around. I don't know if you know what a ho ho is, but snack food from the 70s. Really bad for you. We also learned about concatenating strings and primitives. Java converts primitives into strings just on the fly. So if we say string demo equals Hayes plus 19 plus 81, it's going to hold Hayes 1981. That's because when it adds the 19 to the Hayes, it turns the 19 into a piece of text. And so then when it adds the 81, it also turns the 81 right on the fly. It just turns it into a piece of text. But if we put parentheses around the 19 plus 81, we get Hayes 100 because it has to do the parentheses first. Anyway, there you go. We already learned also about escaped sequences in strings, and these are special codes we use that use a backslash. So the ones I need you to know for our class are \n goes to a new line in a string. Backslash gives us a regular backslash. Backslash quote gives us a quote, and backslash t gives us a tab. So this printout prints out what's down below here. Mr. Hayes said backslash quote, good morning, backslash quote. That gives us these two quotes. And then I did a backslash n to go to a new line, and a backslash t to tab in. And then I wrote, then he typed a, and I gave you two backslashes, which gives us just one when the printout happens. So, whew, it can look kind of crazy, but, I need you to know those. And finally, for today, I'm going to show you some methods. So I already showed you two uppercase, kind of, but I'm going to show you officially here. It returns an uppercase, all caps version of whatever variable you're using the method on. So in this case, I said string name equals Frankie, system.out.println, name.to uppercase. That prints out Frankie, all caps. To lowercase does the opposite. It gives you a lowercase version. Look at how these are spelled. It's to lowercase where the L and the C are capitalized. And if I go back, uppercase, the U and the C are capitalized. That's a common mistake. People maybe don't notice that, but case matters. We have the other one I want you to learn today is just dot length, and it tells you how long the string is. How many characters are in it. So in this example, when we print out name.length, we get 7 because there's 7 characters in the name Frankie. Okay, so today's program has you do some simple operations with strings. It's very short. Go to the Google Classroom and do that coding activity. And remember to get marked present for today, Wednesday, the 16th of September, 2020. You got to turn this assignment in before midnight. Thanks. Hope you're all doing well.